now the reason I want to go through a question like this is that there is, I mean, it's quite a substantial part B, and it's like, well, part B could be a question completely in its own right, but part A is there for a reason.
It helps.
Yeah, they're connected.
You can do part B without having to do part A. You don't need to use them. Like I think you were already saying, I mean, when you add fractions, you just have to make the denominators the same. You can put one denominator with the other side and then put them both on top. You can do that, that's no problem. But this is an example of when you deal with other fractions where you actually want the lowest common multiple rather than just a common multiple, because that's what it is when you're doing fractions. So the reason why they give you part A is because that helps you with the lowest common multiple bit. So I can go through this straight away, or I can allow you a chance to try and work through it yourself first.
Can we try to go through it?
Who wants to have a go at it first? Right, I'm going to give you a chance to go through it. There's enough of it. Let's just do that bit then, just to check, because obviously if you've got that bit wrong, the second bit will be harder. If we factorise that, what's it called? This.
Difference of two squares.
So it is the difference of two squares. Right, and we know then that 9x squared is actually 3x all squared minus 2 squared. Okay, so there's the difference of the two squares. So now we therefore know it's 3x plus 2 times 3x minus 2. Okay?
Oh my gosh, you're sharp, Anna. I'm finding you sharp. What?
Now, we're recording, by the way, so if I've got evidence galore of how you talk to each other.
That's fine.
Yours quite rude.
Now, what
I
you've
didn't say shut up.
noticed,
What did you just do?
did you all notice that this for part A
Yeah.
is here,
Yep.
part B? So there's got to be a reason why it's used in that way. So
I'm wrong about this.
we can rewrite it as, well, it's 4 over, and you notice that
Oh no.
3x plus 2 is there, one of those things, so that's why they're linked. So what we can do, you see, is now we've got this one is 3x plus 2. We know we're going to have to change this denominator, but this one is 4 over, and it's nice to have that because we've got it there, but we've also got the 3x minus 2.
Oh.
Okay? Right. So we've used that first piece of information. Now you've all told me what's the best way of adding fractions?
Make the
Denominator's the same. Now in this case, we only actually have to change one of them, don't we?
You left one.
The left one. So we just need to multiply this by 3x minus 2. So we have to do the same to the top. Okay? Bless you. Now, we can add those two together. Alright? So if we add those together, we get 4 lots of 3x minus 2 plus 4 all over 3x plus 2 times 3x minus 2. That equals 1.
But what about?
But still can't really do anything yet. We could expand these brackets, couldn't we? And
could.
simplify. So, is this the stage? Did you all get to this stage at least, or when working it out?
Yes, I did.
Yeah. So if we expand these brackets, we get
Oh, you get 12x minus 8.
so 12x minus 8 plus 4 all over. Do you mind if I write 9x squared minus 4 again?
That's fine.
Just because it's easier to write. same thing, isn't it? And then that equals 1. Actually, this can be simplified again, so minus 8 plus 4 is actually just
4.
minus 4. Okay. Okay, so I've simplified that left-hand side as much as I can. What do I do now? Now, actually, there are 2 methods we could use at this stage. There's the one I told you about keeping a fractions equivalent, but actually, if you think about it, it's this divided by this. That's what a fraction is. Have we got another method of getting rid of things?
Simplifying across.
Oh, couldn't you just
No, we can't do that yet because we haven't got factorized.
Couldn't
Is
you
it?
just No, go ahead.
Would you those one?
So if we multiply both sides by that, we get rid of it there, don't we?
And then you can just move
And then we end it has to be multiplied to that side as well. Now, I just want to show you this. This is where there's 2 ways to think about doing this. If I choose to multiply by 9x squared minus 4, which is the same as all that, that gets rid of it there, yeah? But I have to do the same to the other side. Alright, so I've got 1 typed. So now I end up with just that equals that. Does that make sense?
Yeah.
Right? Now the other way, which is what I told you yesterday, was instead of thinking of it as multiplying both sides, we could write as equivalent fractions. So I've got the same denominator. But when you do that, what can you do next?
You cancel each other out.
Well, it's not cancelling each other out as such. It's just that because we've got the same denominator, we can we can not add them together. We don't need to.
Just
Get rid of them. We can just kind of forget about them. And do you notice how we actually end up with the same thing?
Yeah.
So you think of it as 2 different ways, but you end up with the same result.
Couldn't you also, before you expanded all of that, bring the 3x plus 2 and 3x minus 2 together?
Yeah, I could do that. Same idea. I don't like the way you say bring it to the other side.
Multiply it?
Yeah, you could just multiply by all of that. I literally just rewrote it because it's quicker to write. That was all I did. You needed to have it in this form to do this first bit, but I just put it back there. But what we actually end up with, you see, whether we do the equivalent fractions thing, so we've got the 1 times all of this is 1, so we've still got 1. Right, whether you do it that way, or whether you do the multiply by this to get rid of it on this side and end up, well, what you end up with is 12x minus 4 equals, so the top equals, so I'm just going to write 9x squared minus 4.
See, this is where I got to.
Got to that point?
Yeah.
And if you got to that point, great. Alright? That would get you quite a bit.
I didn't know how to simplify it.
Yeah, you do. Do the same to both sides. We could aim for equaling 0 because we've got a quadratic. But remember, when you want to find x, you get the same. Do the same to both sides.
Yeah.
So what would you do?
You get
I got it.
minus 9.
You could
Add
add 4 to
4.
both sides.
I could add 4 to both sides. You notice how adding 4 to both sides gets rid of it on both sides. Brilliant. So that leaves me with just 12x equals 9x squared.
How could that be?
Here is where people make a mistake because they move things rather than divide.
Because they would have just moved it.
to the other side.
You have to divide it because we moved it.
Okay.
There's 2 options here.
Maybe subtract.
Okay, I'm going to give you 2 options. So basically, we could, if I wanted 0, what would I have to do?
Subtract.
Subtract 12x. So I've got 9x squared minus 12x. Okay. Alright. Now, how do we solve a quadratic equaling 0?
Polynomial.
You can, or we could start by first trying to
Put it to the equation.
factorize.
Yeah.
Can it factorize?
Yes.
Definitely, there's x. This is a nice easy one because there's no third term that stops you factorizing nice and easy. There's an x in both, so there must be an x outside. And there's a 9 and a 12. What's common to 9 and 12? 3. So 9x squared divided by the 3x leaves you with 3x minus 4. And all of that has to equal 0. Awesome. Now, what do we do at this stage then? So we've now got something times something equals 0. So even if we don't have two sets of brackets, I can put a bracket in if you like, if that helps. So now we know that both brackets have to be made equal to 0, don't we? Same as normal. So we've got 3x has to equal 0, which means x has to equal 0. Or 3x minus 4 has to equal 0, which means x has to equal... No. Well, let's do it step by step. So 3x, so I add the 4. So I've got 3x equals 4. Then divide by the 3 gives me x equals 4 over 3.
Okay. This is a complicated question.
Would they ask you to put it as a decimal or put it on
What would be the benefits of writing 4 over 3 as a decimal?
Easier for you visually.
You can put it in the equation and check.
You can't actually. What's the decimal of 4 over 3?
1.3 recurring.
1.3 recurring. How can you put 1.3 recurring into anything?
You might.
Why can't you?
Because it's recurring.
It's recurring. You can't actually put 1.3 recurring even into your calculator unless you write it as 4 over 3. So 4 over 3 is the exact answer. If you turn it into a decimal and write 1.3 recurring, although you can put your little dot, it's less accurate. But that's the exact answer. That's how we want it. You could, if you like, change it to what?
1 and 1/3.
1 and 1/3. I would say I'm starting this with my year 7s early. Fractions, way to go. Easier, tidier, neater, better looking, just much better than decimals. Much easier to work with. Okay? The only time I like using decimals instead of fractions is it's easier to add and subtract decimals than it is fractions. Multiplying fractions is easier than multiplying decimals. Dividing fractions is easier than dividing decimals. Okay? All of that. Alright? Actually, the other thing is putting fractions in order of size. Put them in decimals, then it's easier. So adding and putting them in order of size. That's the only reason to have decimals for me. Okay, so how do you feel about that question? Good? You get it? So do you understand how you have the skills, but it might have been slightly, if one were to come up,
Yes.
you might have struggled to see, but you do have the skills? Yeah?
Yeah. How many marks
What
would that
other
be
things do you
in
think
like
that-
1,000,003. I don't know actually. I would say probably this part, maybe 1 mark for the factorize. And then for part B, potentially 1 mark for doing this first stage. 1 mark for getting to a simplified form. And then 1 or 2 marks for getting both answers.
only 4 marks?
Yeah.
And it takes you that long.
Yeah. But it only takes us that long because we've been talking about it. Okay. Much of a record. So, if we want to work out the gradient, there's two ways to do it. Gradient and intercept, mx plus c, that's probably the one you're used to seeing. So we know that c, the plus c is
Y-intercept.
the y-intercept, and we know the y-intercept is
8.
0, 8. Therefore, we know that c is
8.
8. So we start with y equals mx plus 8.
8.
Alright? So that's the first bit. Then we need the gradient. And the gradient is, we take 2 points that we know on the line, take them anywhere you like, and we work out the run, so how far across does it go, and then we either go up or down to work out the rise. So we have a negative rise, right? And how far have we gone? So our, remember, gradient m is rise over run. So what's the rise? Well, we know it's negative because we go down, so it's negative.
1.
From 6 to 5 is
1.
1, and the run was also 1. So we have negative 1. So the equation of this line is y equals negative 1x plus 8.
Will you still write the 1? I thought we do.
No, you wouldn't have to. But it does ask in the question for what is m and what is c. So we would say m is negative 1 and c is 8. That's what it's asked you for. Does that make sense?
Yes.
Cool. Alright. So we've then got another set of information, which is Alex.
X is greater than or equal to 1. Y is greater than or equal to, I mean less than or equal to,
Yeah. Less than or equal to
mx plus c. Y is greater than or equal to x plus 2.
x plus 2.
And y is greater than or equal to 4.
Okay, so what we have there is 1, 2, 3, 4 inequalities, and each inequality is represented by a line. So actually we are looking for x equals 1, y equals, well, we've already worked out it's minus x plus 8, and then we've got y equals x plus 2 and y equals 4. So they are the lines. These are the inequalities. Okay, they're the inequalities. These are the line equations. Okay? So we have to kind of identify which one's which. So let's start with which line is the x equals 1 line.
The pink up and down one.
The pink up and down one. So this is here.
Yeah.
This is the x equals 1 line here. Right? So I'm just going to go that one now. Right, now the inequality says I'm allowed only where x is greater than that line. So I think, well, if I'm travelling in an x direction, I get stopped at x is 1 and I can't go below it. I'm only allowed above that line. So the x direction with this line is that way. So I'm only allowed to go in that way, which means if I'm shading what I'm not allowed, I'm going to shade this side. So I'm saying I'm allowed to the right bit. I'm allowed x is greater than 1. Okay. The second line, well, we've just looked at, is this one. And we're allowed where y is less than x plus 8. Minus x plus 8. Now, is that above or below the line? Well, this one's a bit, it's maybe not as obvious, so we just got to check. How do we check? Well, let's check one of the signs. We don't have to do both, but we'll check. Let's check a coordinate 3, 3. Let's just check and see whether. So we're allowed when the y coordinate is less than the x coordinate minus and then plus 8. That's the one we're allowed. So we are either allowed that one or not allowed it. So let's try. Is 3 less than or equal to minus 3 plus 8?
No.
No, it's not. That is not true. Therefore, I'm not allowed that point, which means I'm not allowed any point that side of the line. So actually, I'm going to shade everything under the line.
Yeah.
All right? That makes sense? Then, the next line is the x plus 2 line. Which line do you think that is? I've kind of half covered it up, but the x plus 2 line is this one. It starts at 2, crosses at 2, x plus 2. And I'm allowed where y is greater than the x plus 2. So because there's no negatives in this one, it's nice and easy because it's going to be above the line. But we could do a check again if you like. Let's pick a coordinate 3, about 3, 6. So 3, 6 is above the line. I think I'm allowed to keep that. So if I check, I'm going to go 3, sorry, what was it? 6, sorry, has to be greater than or equal to 3 plus 2. Is that? Yeah, so that's fine. So I'm allowed to keep that point, and therefore I'm allowed to keep any point above the line. So I'm going to actually shade
Leo. And you told them.
I think something's gone wrong. I think we've, yeah, I think we've done something wrong. But yeah, I think we've done something wrong. I'll ask you to spot it.
Okay.
Just because at the moment the final line is a bit redundant because it's below, it's in the region, when in reality, oh sorry, the next line would be the y equals 4 line, which has got to be this one, and I'm allowed when y is greater than it, so that'd be above the line, yeah. So that would leave me with this region, but that line's a bit redundant. We have done something wrong. What have we done wrong, Lucy?
Is it that y is smaller than or equal to
Why? Which one? Sorry.
y is smaller than or equal to mx plus c?
Yeah, because look at it. We're saying y is less than or equal to mx plus c. So we've got 3 is less than minus 3 plus 8. And I said, is that right? And you were, oh no.
It's true.
And in my head, I was like, no, it's not. I made the mistake as well. But I'd look at that and go, that doesn't look right. So I better just check. And I looked at that and went, what is minus 3 plus 8?
5.
5. Is 3 less than 5?
Yeah.
Yeah, it is. So actually I shaded the wrong side. So that was here, wasn't it? So the bit under this line I should have shaded above the line, shouldn't I? So I should have shaded there. Right? So I was allowed underneath.
Oh no.
Yeah, I know. But it happens. What are you going to do in an exam if you spot this? And then y has to be greater than, so I've got to shade underneath the line. And I already decided I'm allowed to keep above that line. So actually, the region I'm allowed is this little one here.
Which one?
Here. Put an R in it, just to be sure.
Let me do a proper inspection.
So although you kind of, it's, sorry, you made a mistake, it's good because if you do it in an exam, which is likely you will, I mean, I made the mistake, hands up, I didn't spot it either, I just kind of just too many numbers, too many lines. But when you get to a stage at the end and you think, now it's almost like that could have been right, but they don't write questions like that. They don't leave that as the space. They have it as one of the ones in the middle, normally. So it should suddenly send alarm bells and go, I'm not getting the thing that I expect to get. Doesn't mean I'm wrong, but it is worth checking, which is why I went back and checked. Does that answer your question, Alex? Is that, yeah?
Thank you.
All right, does anyone else have anything they'd like to go through? Are you all happy with each stage of what we did there, with that one?
Are we not allowed to do another one of these things?
You're allowed, I don't think I've got one to hand. There's plenty in your textbook. You've got the next one.
Are you allowed to?
Alright, let's, should we go through the, well, I'll tell you what, the second one, do you want to just have a go at it yourself first?
Yeah.
Alright, and I'll draw it, so when you're ready we'll go through it. Right, let's go through it then. So, what we've got, 3 lines, 3 inequalities. The y has to be greater than 3, so again, we're going in the y direction. We're stopped at 3 and we're not allowed to go below it. Okay, so y has to be greater than 3. So this is the line that stops you travelling in the y direction, and we have to be above it. So I'm going to shade below. Okay, that one's done. Then y has to be greater than 5 times whatever x is. Now which line is that? Well, this line has a nice steep gradient of a positive gradient. So there's the 5x line. This is the... How do I know it's 5x? Because it's 5x plus 0. So it crosses at 0. And it goes across 1 up 5. Alright? The other one to know is that, we did talk about this a few lessons back, equations like x plus y equals, whatever the number is where it crosses. X plus y is equal to 6, crosses at 6 and 6. Because then you know, remember I've done this before, 0 plus 6 makes 6, and 6 plus 0 makes 6. So there are your coordinates, 0, 6, and 6, 0. So this line is the x plus y being 6, 1. Alright? So this line is the y equals 5x. We know it's a positive gradient, a steep gradient being 5. So we're only allowed where it's greater than. So again, we could do a check if you like. A coordinate here is 1, 5. So x is 1. 5 times 1 is 5. Is 6 greater than 5? Yeah, so that's the one I'm allowed, so I'm actually going to shade below it.
Even that little triangle?
Even the triangle. So this is where you can't assume it's the one in the middle. But what it is, there is an option. So we've got x plus y has to be less than 6. So that's going to be below this line. So we shade above it. So our region is actually this one. Okay? Now just check, did I read all those equations right? Okay, y has to be greater, but yeah. Okay? So that's an example where the region, what do you think they're hoping to trick people into doing? Thinking it's the triangle. Because quite often it is. You fell into that trap. But at least when I've done it, it is a region that seems reasonable. I might go, well, I think it's probably, I'll have a check. Can anyone spot, did we do anything wrong? No. Now, don't forget, how big is this region? No.
We don't know.
3.
It's infinitely large. Why?
Because there's a lot of
Because what happens the other side of this line,
it's negative.
you go into negative values. So R is actually, if you included negatives, which we could, huge. It's big. Like if I were to shade that in a different colour, we have this, but we also have everything in the negatives too. Right? So sometimes they also add a 1 in that would be x's has to be greater than 0, for instance. Okay, that's that one sorted. Any questions on that? You alright? Any further topics you want to go through? A lot of you have been going on probability, Venn diagrams. Yeah, 2 of them. 2 questions.
These questions, I just need
probability. Write this as a plural.
Yeah, so for instance, just don't forget when you have Venn diagrams, there's a couple of aspects to Venn diagrams. One is, if here is a Venn diagram with only 2, well, let's say we've got to go up to 3. There's 2 things, isn't there? So you have to be able to put data in the correct regions. So A, B, C. So if we say someone is in group C but not in group A, where could they be?
in group C and B.
So they could be anywhere there. Alright? So we can do it by words, but I would also expect you to be able to identify when we write things like that.
A intersection B intersection C, which is the middle one.
Which is the middle one. Okay? Do you remember B union?
Yeah.
B,
So that's
C,
everything
not
in A.
So it'll just be
Everything in A that's not in B and C.
So we say right, everything in B and union means you can have both bits. So we're allowed then basically to shade in all of B and then also everything that's not in C. Yeah, got to remember to. Now, what some people then also think is, oh, but I have to get rid of this bit because it's in C and I'm not allowed not in C. But you are, because you're allowed everything that's in B regardless of any other rules.
Why is there C left over?
Yeah, exactly. They're 2 different things.
Is that little part A still there? The brackets?
This bit,
They're not.
that's still blank
If
because
it's in brackets,
it's not in B and it's
That applies to everything. Yeah.
absolutely it's in C.
but it's not in C.
Everything.
Yes,
So
but the stuff
everything
that's not unionized.
So the shaded stuff
Right, so let me, hopefully what, I would love to have that transparent film stuff, because when you're doing this stuff, the thing with unions is, so if I were to consider this, basically, I think Alison said it quite right, is if you consider them as 2 separate diagrams, alright, and you do, let's draw these quickly, right, so if I do A, B and C, so if we were to do a union, you can think of it as take all of B, right, and then take all of not C, right, and then because it's a union, you just overlap one over the other and see what you're allowed. So the bit that I'm allowed is obviously that bit in there was not shaded, so I'm allowed it. This bit is in both, so it's fine. So union is when you are allowed to keep both. But intersection, if we were to do B intersect not C, that would be a bit different, because what does the intersect mean? When they both meet. So which bit appears in both diagrams, I would say? So the only bit that is in both, come on, is I've got this section here, right? That there is in both things shaded. The rest of it is not. So the intersection one is the one that's been done twice. The union is just chuck it all together and make one big mashup. You know what I mean?
Got that.
Got that?
Yep. That's a good idea. I might love to.
And then, of course, with Venn diagrams, you've got. So we'll just make something up. It's just a simple one.
Says, you don't know. I'm asking you, I'm not telling you. I go to the Bible.
So, let's think of it as piano players,
Guitar players.
flute players, and guitar players. And we've got 3, 2, 1, 0, 4, 6, 2. Okay? 7. Right? So if I said to you, I'm going to pick a person at random, what is the probability that that person plays piano?
It would be
12 out of how many?
So piano, 3, 2, 1, and 6.
12 out of whatever there
So
is.
12 out of them all added together.
yeah.
And then
Yeah. So what is that? 7, 8, 9, 10, 16, 21, 25. Okay, 12 piano.
Yeah.
Right? What's the probability of playing 2? Exactly 2.
6, 8.
So 6, 2, yeah, 8 out of 25. What's the probability that they play flute or guitar?
So that's 12. 6, 12, 13, 14.
6, 7, yeah, 30, 14, 15. Because it's like doing a union and or, all of them and all of them, so, right? What is the probability of playing at least 2? So we've got the probability of playing 2, but what's the probability of playing at least 2? 9 out of 25. Why? What was included this time that wasn't before? The middle one, because they play 3, but 3 is at least 2.
Yeah.
Yeah. What's the So if I said, given that they play guitar, what's the probability of playing flute?
So then that would be 6.
7.
1. It's 1.
Right, be careful. What's the probability? 1 out of.
Out of no, it's 1 out of 8.
What's the number up there?
6, 7.
Okay.
No, it's 1 out of
Well, you can see it all. The probability.
That's the
1 out of
guitar.
9. 1 out of 9.
1 out of 9.
1 out of 5.
7, 8. Oh, I forgot the other 2.
Yeah.
Okay? It says given that they play guitar. So as soon as you've got a given that changes the denominator. So I already know that they play guitar. So that limits me to only those 9 people. Alright? So that's basically it for probability. A few of you have been asking about probability. Anything else you kind of issue with? So there is the Venn diagram, like you've got to fill the data into the Venn diagram, yeah. So you've just got to remember that if you are told, for instance, let's change this just a little bit. If you are told that 9 people play guitar,
Yeah.
do you stick 9 there?
Yes.
No.
For the time being.
Okay. What I would actually do is stick the 9 there. Because you know that this, and this has got to. Because then you were told that, you know, 2 people play all 3. Okay, now I've got that.
So that means that
5 people play guitar and flute.
So that's 7.
So this is 3.
Oh. Huh?
5 play guitar and flute.
Oh, it's
Both of those regions, yeah? Alright. 3 people play guitar and piano. 1, because 1 and 2 make the 3.
Oh, yes.
So therefore 9 play guitar. What goes in this one?
3. Yes.
They add up to 6. That can only be 3. So there's your problem solving ones. Alright? Don't forget your basic algebra. E times 3e.
That is
3e
4e.
squared.
What? Go alive.
I thought I got it wrong.
Solve 5x plus 12 equals 24.
So you do 24 minus 12 on both sides.
So it's
5
x.
over 12.
X is 12 over 5.
12 and 5.
That's
Okay?
What's that?
You're saying it
Either
either
way. What's that trick, like equation for finding the something like that? It's like y2 minus y1 equals x2. No, x2 minus x1.
Oh, right, okay, yeah. The equation of a line. Y2 minus y1 equals m times x2 minus x1. That was just for finding the equation if you've got 2 points. If you want to do it that way. So if you're given 2 coordinates,
What does m stand
gradient.
No, can you tell?
Parallel lines, what do you know about them?
Same gradient.
Same gradient. Perpendicular lines,
Negative reciprocal.
negative reciprocal. Okay. Okay. Stop looking smart. You're making her feel weird. Okay. So no particular questions, yeah? You're all happy. Just relax. Okay? Relax about it. If you've got any final, like I said, if you've got any final questions, we've got 20 minutes or so before the test. You can ask them. If not, we can always just get on with it and you can finish a bit early and relax afterwards. Up to you. Whichever one you prefer.
I'd like to relax.